All right. So, hey everyone, welcome to the call. So this is part of EPRI's ongoing DER data and connectivity task force, where we host a number of discussions with utilities about new emerging technologies, or in this case, a standard, that are coming up, and then having an opportunity for utilities to hear from each other and discuss these new technologies. Today's call, we're actually co-hosting with MESA. Darcy Wheels will be representing them on the call. And we're going to be talking about the 1815.2 standard and hearing from some folks, some utility peers who have been applying it today. The goal of 1815.2, if you're not familiar with it, and Darcy will go into some more depth in a little bit, but it's essentially to set clean, consistent, and interoperable data structures for utility DER communications. So it's helping us to avoid all of the naming convention discussions, talking about units, and trying to get closer to actually having a shared data layer that both utilities as well as your partners understand. So making that whole process faster, cleaner, less painful, and hopefully cheaper too. So, and if that doesn't make a good case to learn more about it, I've got another one. If you're familiar with IEEE 1847 or working with export capable DERs, this is also another important standard to be aware of, because its predecessors are already required in 1547/2018. And the latest draft of the 1547 revision that we're working on right now actually references 1815.2. So when you see that next version come out, it will actually call out this standard itself. So, and as you'll hear today, utilities are already starting to point to it in their requirements for all types of export capable DERs. With some specific value with energy storage systems. So let's talk a little bit about the agenda for today. So today's call was sort of in a response to a number of questions that we've gotten from utilities over the past year or so, where they've been interested in 1815.2, but a common thread has been that they're really interested to hear more from utilities who have worked with it and learn how they're actually using it and those experiences. So for today's call, instead of walking through the standard itself, we're collaborating with MESA to put together today's call, to hear from peer utilities, to share practical experiences, things like what worked, what surprised them, and the benefits they're already seeing applying it. So we'll kick it off with an opening from Darcy about the MESA organization, 1815.2. Then we'll hear from Gabe Leggett from SMUD, Nick Peretti from Snohomish PUD, and then finally we've got a double feature from SRP, Daniel Abramson and Ryan Tanner. We'll talk about their experiences. And today's discussion is meant to be casual, so if you have questions, hop in, use your hand raise feature to let us know if you've got a question and you want to speak up, and also feel free to participate in the chat. We'll be watching that. And one more thing, we're also going to be conducting a poll, which I'll launch in just a moment. It should pop up on the side of your WebEx, and it's a couple questions about your interest in 1815.2, where you think you may use it, and if you'd like some more information from the program that Darcy is going to touch on later today. So with that, looking forward to the discussion, and I'm going to turn it over to Darcy.
Thanks, Ben. All right, I think I can move the slides now.
Yep, looks like you got it.
All right. There we are. So Darcy Wheelis, I'm the Executive Director of the MESA Standards Alliance, and I've been with the Alliance since it started a little over 10 years ago. I want to tell you a little bit more about MESA and 1815.2. MESA stands for the Modular Energy System Architecture. So we're looking at what are the underlying, what are some of the foundational communication protocols for DERs that would benefit everyone if they were if they were standardized to create more interoperability. So that's what MESA focuses on. We focuses on DER communications and trying to make them better so everyone can deploy faster. Our mission is to accelerate the interconnection of these DERs by creating interoperable communication standards or specifications. And we start with well-established. We don't want to standards. We don't want to go out in left field and create something new or reinvent the wheel. We're really working with what you guys are in the space you guys are already in. Specifically, where does MESA work? If you look between your SCADA systems and DERs or DERMS, That's what we used to call MESA DER. It has now been incorporated into IEEE 1815.2. So that's this area right up here. That's what we're going to focus on today. We also do some work at the Modbus level, and that's for the components of an energy storage system, and that's the SunSpec storage models. So let's dive into 1815.2 a little bit, and we could spend an entire hour just going through this. And spoiler alert, we have some workshops coming up that will do just that. But essentially, at the highest level, 1815.2 creates a profile for DMP3 that is specifically for the communications for distributed energy resources. So most utilities use SCADA systems, and SCADA systems use DMP3. So that's why we chose that protocol. And then why do we need another standard? Well, there's a lot of DERs on the system, and there are many, many more on the way. And so if we can standardize these communications, it will make everything go faster. That interoperability is key. It saves utilities money on integration. It allows vendors to develop products with more certainty. It also provides cybersecurity using SAV5 and eventually SAV6. And I think one of the most important things is the scheduling capabilities in 1815.2. 1547 has some initial scheduling capabilities. MESA greatly expanded upon them, and that has all been incorporated into 1815.2. A little bit of history. Where did it come from? I said we use things you're already thinking about. I wasn't kidding. We started with 1547 functions, and then we had the semantics from 61850. MESA's work, as I said, expanding those functions, creating a spreadsheet, and then taking the DMP3 app note and really mapping 61850 data objects to specific points in the DMP3 data points. So wrap all of that up, and you have 1815.2. Again, not going to go through all these functions, just want to touch on them and show you. On the left, you have the 1547 and the California Rule 21 functions. And as you can see, MESA's work on the right from MESA DER greatly expands those functions, and most importantly, including the scheduling. So I think you have a lot more use cases that can be supported using 1815.2. Okay, so why do you care? What's in it for utilities? You have an internationally adopted standard that's been vetted by your peers, by EPRI, by technology vendors. It's gone through the ringer, and that has gotten a lot of the kinks out. You can point to the specification, and one of my main requests is that you add 1815.2 to your technical specifications, that you include it in your RFPs and any of your requests for utility scale DERs, storage systems, microgrids. That's one of the ways that you can really promote adoption. And if you want to even go a step farther, you can require testing and certification. This will reduce time and costs of deploying these DERs. You don't have to spend weeks integrating, getting the SCADA engineers at the last minute right before commissioning to integrate and get whatever system you're trying to bring onto your grid to talk to your SCADA system. As Ben mentioned, this is going to be referenced in 1547. So if that's important to you, this should be important to you as well. And also, if you're moving to IEC 61850 in the future, this is a great first step because we've already done the mapping. Let's see, with that, I'm going to pause. I'm going to talk about testing and certification a little bit later, and I'm going to hand it off to Gabe.
Cool. Can everyone hear me?
Yeah.
Okay, perfect. For some reason, my WebEx wasn't working, so I had to switch over to the web-based version of it. So I'll see what I can hear here. I'm trying to see. I may ask to have my slides moved for me because I'm trying to see if I can do this. Okay, well, we'll just start here. So I'll just jump in. So I'm Gabe Leggett, Principal Engineer and R&D at SMUD, Sacramento Municipal Utility District. We've installed a 4 megawatt, 8 megawatt hour lithium ion battery system And this was a couple of years back. The hope was really to, learn about lithium-ion battery systems and how, how they operate, what's the lifespan of them, degradation that'll happen year to year, so that could feed into our large-scale power purchase agreements. But also we wanted to understand, how are we able to communicate with this system using DMP3, the distribution network protocol, and then establish a standard within SMUD so that as we have more DERs come into our system that are going to be interconnected, that we're able to control them, monitor them, and then it's the integration is much easier. Prior to coming to SMUD, I worked at San Diego Gas and Electric, and we were attempting to hit a 2020 energy storage target, and so we had between 7 to 11 different battery systems with different manufacturers. The integration into our SCADA network was taking close to about 6 months per site. And we would have to kind of train our staff on how each one operated slightly different. So when I first heard about MESA, I was still in San Diego. I met Francis Cleveland, who talked about, hey, we have this DMB3 map already for you that has object models, it has the scaling factor, it has the operational modes for your battery system that you can establish, and then just send this out to your vendors to say, hey, please meet. And at that time, it was called MESA DER or MESA ESS. So right now at SMUD, if we have a generation facility, so usually it's solar or a battery system greater than 500 kilowatts that requires a power production meter, and then that requires it to be incorporated into our SCADA network for the ability for curtailment as well as monitoring and control. So the pilot project that I was talking about, this 4 megawatt, 8 megawatt hour battery system, we used a full implementation of MESA ESS, which is now 1815.2, and we were able to test out a lot of these operational modes. Can we go to the next slide? Let me see if there's a way for me to do that. Okay, here we go. So this is our battery system. It's 6 containers, 6 20-foot containers, uses lithium iron phosphate, a type of chemistry for lithium ion. It was energized in 2021 and fully commissioned in 2023. Over here on the left, I have a list of some of the MESA modes that we implemented. Primarily, what we're using it for is just scheduling, so it charges during the day and discharges at night when prices are expensive. So scheduling function is very important for us, as well as when we start to move the system into market participation, potentially, we're going to use the automatic generator control, which is taking a signal every 4 seconds and then changing its active power target to meet a distributed operating target. So a signal from CAISO or from a power system operator. Let's go ahead and move to the next slide. So a very similar slide to what Darcy was showing. At the time, it was MESA ESS. So really what we're looking for is a way for our SCADA network utilizing DMP3 to communicate with any type of DER or energy storage system. So we wanted to be completely mapped, to be standardized, and then make it so that anytime somebody's interconnecting, this interconnection process or integration process is going to be take weeks rather than taking months. Was there a question? I think I heard someone. Oh, okay. The other thing is at that time when we did this system, we did not have testing and certification available through MESA. So this is great that that's being offered. We had to work with our vendor at the time to kind of just create our own testing and certification process. Now that this is available, we're going to request our vendors to meet 1815.2 and to go through a round of testing and certification so that we are looking for more of a plug and play integration, at least at our control side. Also, MESA has developed an implementation guide. This is something that we requested. Because when we were working with some of our vendors, they were saying like, yeah, great, we have the MESA standard, we have 1815.2, but we've never really done this before. And with the implementation guide, it goes through a couple examples where, this is how you would implement the scheduling function. This is how you would implement AGC. There are certain points where it says certain things are optional. It really highlights what are the things that are going to be a requirement to make this function work. And it just kind of goes through example through example that you can hand over to your vendors, and that they'll assist them with testing and certification. Okay, go to the next slide. Yep, and then on the final slide, I wanted to show, so we have an advanced distribution management system, moving on to our distributed energy resource management system, and what are the kind of protocols that we're trying to support. So 1815.2 or MESA ESS really is going to be for those front of the meter greater than 500 kilowatt generation sources or energy storage sources. But we also do support kind of behind the meter communication protocols, which would be IEEE 2030.5 and OpenADR. But we're looking at really having, kind of these three communication standards to determine what is behind the meter, based on what's behind the meter or front of the meter and the size of the system, to which communication protocol and standard you need to use. And so with MESA 1815.2, especially in DERMS, at a minimum, it's going to be the DER disconnect and reconnect, automatic generator control. Because with AGC, what we're able to use is our DERMS basically run an algorithm based on input data to see when is the best time to send out a fleet-wide command for charge and discharge. And that battery system is just capable to accept that signal, change its active power target based on the output from our DERMS, and then also be running a local volt var or a frequency watt to help for grid stability. Okay, and let's think that'll be it for me. Okay, I see a question in here. What is the response for DER customers who are required to comply with the standard? Usually we're able to let them know ahead of time that we're going to require 1815.2, and they're very responsive to it. I think some of the challenge could be is there a company that focuses on controls that has implemented 1815.2 or MESA ESS? So we have worked with a couple companies, so sometimes we may recommend like, hey, we've used them in the past. These were the ones to move forward with. It just, when we find a lot of companies that say are just a battery company, they have to outsource their controls to somebody else.
Gabe, I have a question. Joel from
Sure.
SRP,
Mhm.
your friends over here in Arizona. A question about what does it look like for your distribution system operators in the control room? Are they able to see the output of these solar or microgrid systems? Can they control them? What does that look like?
Yeah, so we do create an ADMS screen, so advanced distribution management screen. So we'll be able to get down to, for example, that battery system that I was talking about. We can see the 6 individual containers, information on the power production meter. We can send controls to start, stop. Also, right now it's operating remotely, so we update the schedule. It's a 24-hour dispatch schedule, so we can update that daily. Now, what we would want to see will kind of depend on the agreement with the customer, whether they're going to give us control of the system or is it really just monitoring. But either way, even if it's monitoring, we're going to do 1815.2 and then just use those monitoring data points and use cases. We also request to have the ability to, in an emergency, isolate the system. So DER disconnect and reconnect. And then potentially be asking to provide some type of grid stability, so voltage or frequency support. Okay, any other questions? Okay, I think I'm ready to hand it off.
Sounds good. Thanks, Gabe. I appreciate it.
Mhm. Thank you.
Let's see. Up next is Nick Peretti. Nick, are you online?
Yes, I am. I'm here. Can you hear me?
There you are. Yep, I can hear you loud and clear.
Perfect. Let's see. Okay. Yeah, so this is Gabe, I appreciate your presentation because in a lot of ways, us up at Snowpud tries to learn from Gabe as much as we can, and we see his architecture and what they're doing there as a great roadmap for what we could do here. Obviously, every utility has its own ecosystem, so there's uniqueness to both of ours, but I think Gabe did a great job of setting the stage of how you actually apply this stuff. So we'll go into that here, but we'll start with looking at like, I really want to set up our project, like our big project that we're working on. We have a 25 megawatt, 100 megawatt hour project that's being commissioned in the fall this year. And our ability to build DERMS to control that system is all based off of our confidence in 1815.2 being the guiding, standard in which enough brains have been put into that effort that we feel confident that we can lean on it for our controls. So yeah, it's an exciting time, and I know 1815.2 plays an important role for us. So we'll talk about our market. We'll talk about our resource strategy. We'll talk about IEEE 1815.2 being the driving force of our confidence in controls, and then expanding that architecture, and then lastly timelines. So let's go to the first slide. Okay, so our story is a lot about our IRP, like integrated resource plan. When we started out, we were going to build this battery for regulatory compliance reasons, but then we switched markets, and so now our driver is performance, which is great for me because I always enjoy battery performance, battery capabilities, battery functions. I always believe that they've got capability not just for a spreadsheet, but for their actual work, and so being kind of able to flip the value from 80% compliance and 20% performance to 80% performance and 20% compliance was an exciting opportunity for this battery to kind of change. And then that drove our need for a really confident strategy for control. And 1815.2 is obviously the most capable to kind of meet our opportunity and provide reliable functions and scheduling. So yeah, that's where we are now, and that's why we're building our battery. So yeah, let's go to the next slide. So when we start thinking about what we're after, we built our battery for this reason here. We have our peaks, and we're shaving that peak. We believe we'll have customer response programs, behavioral response programs. We don't want to call those a lot, so just once a month. But batteries are going to be called often. So this big battery is being that orange slice there. Being called nearly every day, and our goal is to reduce our peaks. So this is kind of just giving you an idea about as we develop out our strategy, and while we're leveraging 1815.2, these are the resources we'll be thinking about. So the green slice is customers. That's not 1815.2, but everything below that, excluding time of use, would theoretically fall under 1815.2 for controls, or like Gabe was saying, 2030.5 for smaller resources or open ADR. So let's keep going. So this is, the reason we like having, IEEE 1815.2 is it makes a guiding standard, right? We can hand this to our programmers on the utility side and say, hey, this is what we're controlling with. And I can hand it to the builder, the DER, the aggregator, and say, this is what your control software has to be able to take in. Now, how each side does that can be however they want to, but ultimately it's DMP3 and this point structure for ownership, right? And so for our big battery, they're actually running an OPC UA conversion from DMP3. So they basically have an 1815.2 box locally that they own, that is then taking that and converting it to another protocol. And that's up to them. They preferred ignition for their SCADA system of the local battery system. And they just took it on themselves to do the 1815.2 conversion because it's part of the standard and the requirements of the project. So, and we're cool with that, right? That's their reliability. That's their system, and they'll perform to the standard for when we kind of exchange ownership of that data. But 1815.2 gets to be the ownership exchange medium, which is really helpful. It's also really good when you're going through the kind of functional design spec with those stakeholders. a lot of times questions will be asked, and it gives you a little window of who's read the standard and who hasn't, right? 1815.2 has a lot of structure built into it, a lot of confidence, a lot of features and assumptions that are healthy to take. And so when you start hearing questions that are reflected in 1815.2, you can always help people to say, hey, you don't have to come ask me. You can go ask 1815.2, go read the documents associated, and you'll get a good sense of what we're after, and then come ask me. And so it's really is just a great opportunity to have a guiding light that you just said, you don't have to trust me. You just trust this, industry approved, internationally approved standard. And that will give you more confidence that you're not doing a one-off project with me. You're doing a big project for everyone else that's also operating on this standard. And the lesson learned that we have with our customer on implementing 1815.2 will get fed back up. So it's pretty exciting to have. And then once we have this pointless architecture, we can cut it up however we want, right? Our old SCADA system for our utility required linear indexing. And if you know what that means, it just means that we don't do jumping indexes. If you're going to have index 1 through 10 and then jump to 50, you have to have spares in between 10 and 50. But now that SCADA systems don't require that, and there's DP3, processes and architecture and equipment that don't need linear indexing, you can just do tag processing and such like that. But you can jump from indexes to index. Now we have one point list that can be the master index list for multiple systems, multiple client outstation relationships, reverse relationships, and you can kind of reference the same points. What it means for us is that we don't duplicate point meanings. Like point meanings, it'll always have the same tag, it'll always have the same index. It's just whether or not certain systems are leveraging it for what they need, whether that's emergency response, control, and DERMS, or just situational awareness for the crews on site. All of that is kind of built off the same guiding document. And it's like, oh, well, I use points 5,000, but they don't. And that's okay. It's just that point is reserved for that function. And so the DER operator kind of knows there's a structure of all the systems that are going to want their information or control their system. They won't have duplications of indexes. So really great to have. Go on to the next slide. So once you have your guiding principle, then you start building out your architecture, right? So now that I've told our DER builder aggregator to allow us to communicate, control, telemetry through 1815.2, now you go back to your team and you say, how do we build our architecture around it, right? And this comes down to how does your company operate? How do you make sure that this really strong document, 1815.2, is supported through your entire ecosystem of a company? And that's where you start getting into DERMS. So for us, 1815.2 is acting as the authority in how you can build out your first DERMS understanding or your expert, right? And so then you build out that architecture and say, hey, if we are going to build our DERMS around the functionality of 1815.2, that then ends up being the cornerstone of the development. And everything out from that is flexible because it's a lot of human processes that are a little bit more flexible and are ready for the change, maybe not. And you kind of have to have the people ready before you can change all the processes anyways. So you just kind of start from 1815.2 and you build out from there. You have a relationship with the DER, then you build out to what your DERMS is doing, who needs to be in the know, who has authority over in the loop processes versus out of or over the loop processes, and then who might be integrators that need to integrate their system softwares with your DERMS. But 1815.2 still stands as kind of like the catalyst of the process, so that you can always point back to that functionality that you're after to then build out your other architecture. All right, next. And then you get to a roadmap. So you have your guiding cornerstone, 1815.2 for us. That's our guiding cornerstone. Okay, we're expanding into 2030.5 and open ADR. And then you build your architecture, which is really how do the humans, exist within 1815.2 and the DERMS ecosystem in which 18.2 is being leveraged. And then you have a roadmap, right? So now you've got your devices you're controlling, you've got the protocol you're using to control them, you've got your architecture for your company, and now you build your timeline. And that's where you say, okay, these are the integrations, whether it's personnel integrations, right? You need to get the people trained for the moment, or the software integrations that you need to kind of make this system work the way that you want it to. And so you build your 4 or 5 year roadmap and start getting those product pitches and coordinations rolling. But it all comes from the cornerstone of 1815.2. I think that's it for me. There might be questions. I'm not sure how to get to the chat. Oh, there it is.
Let's see, there's been some discussion, so they probably shuffled around a little bit since last time you looked.
Okay.
One question I see from Leon at P&M said, do you need additional hardware at the PCC to effectively implement? What's been your experience?
No, at our point of common coupling, which is inside of a pretty traditional switchgear, we have the same substation equipment that we use for our distribution circuits. It's basically the same spec. The only thing that changed at our point of interconnection for that switchgear is the metering range, right? Because we're dealing with, we need better resolution, and our balancing authority needed better resolution on that. We had to add in higher capability CTs, which was a pain. It was about $100,000 deviation in cost for the switchgear. But that was it. As for like the point of common coupling for controls, we also didn't need a new device. They have the ignition, they have the ignition software running and the converter on the same, software system or computer, basically. So ignition and Kepware are the two softwares that they're leveraging locally for that kind of point of common communications, we'll say. PCC.
How are you orchestrating all the different individual units of generation, like individual inverters or ESS inverters? How do you orchestrate them in a dynamic network array?
Yeah. So, ours, we go by the philosophy that if it can be aggregated, it should be. So all of our systems, they're aggregated by Tesla themselves, right? So Tesla's the battery manufacturer. So they are aggregating it to their system controller. They simplify the controls at their point. Then they hand that to Trimark, and then they further simplify it, or maybe even make it, I guess, Tesla's maybe is like even more simple. And so the harder work is then taking those simple controls that Tesla has and expanding it to the capabilities of 1815.2. So the individual balancing happens at the Tesla level, but the actual like orchestrating of that balanced system happens at the Trimark ignition level.
Thank you.
And then I saw one other comment from Neil Cumming, said, love the concept. What's been the response from DER customers when you're requiring compliance to the standard?
Yeah, we actually have a pretty interesting way that we got here. We put MESA in the standard, and actually technically we left it open to say you can use another industry supported DER communication architecture, which we sort of knew MESA 1815.2 was the only option, but we did want to leave them the flexibility to introduce the competition to 1815.2. And they came back and said like, oh, we're going to do this proprietary OPC UA, and we've already secured the contract, so we don't really want you to make us change our minds. And we go, well, no, like the contract for the service required a industry standard, right? Not just a proprietary communications strategy. So they were bummed out about it, but ultimately they read the contract and they said, yeah, you're right. Like, we would have loved for you to agree to throw that part of the contract out, but we said no, it's not an industry standard, and the only one that we are aware of is 1815.2. So they ended up saying, okay, yep, you're right, like that's our analysis as well, and they went for it. It's still, it still is a bumpy road because they've got a lot of projects. I mean, these DER integrators, aggregators, they're trying to do everything they can to minimize the cost of delivery, MVP, lowest or minimum viable product, and doing 1815.2 is not like the easiest thing in the world, but it's worth it. I guess that's the point. For us, it's worth it, and we'll pay for it, right? When we put that contract out there to say it needs to be 1815.2, we're hoping those programmers are doing their legwork to know how much that takes and bid accordingly, and then deliver it because it's worth it.
And then maybe one more, and that we got another question from Richard. It says, "Are you implementing DMP SAV 5 or 6, and what you're doing with cybersecurity for DMP while using 1815.2?"
I haven't had to be too involved with the security because all of our substation equipment is built around 1815.2. I will say that like when it comes to like NERC compliance and SIP compliance, there is some, firewalling rules and stuff that get into the mix, but all of it's solvable. Yeah, so we leverage our existing DMP3 architecture for all of our substations. We just say, what if we do that for a DER? And that's the same safety and security that we'll have of that system, and then maybe just a little bit extra firewalling rule because we have multiple authorities, right? Our substations we fully have authority over. A joint product where we own the substation and they own the batteries. There's a little bit more lines of delineation there.
Awesome. Thanks, Nick.
Yeah, thank you.
All right. So next up, we've got Daniel and Ryan from Salt River Project. Let me see. I'll pass it off to you now.
Thanks, Ben. So I'm Ryan Tanner with Salt River Project, engineer in a group we call Distribution Integration. So a lot of what we do is kind of R&D and projects to integrate stuff with the distribution system. So one of the and some of the other stuff we do is support our operations center. So we do R&D and support our ops. So we get both of those groups input and help implement stuff on the distribution system. And I'll let Dan introduce himself real quick.
Thank you, Ryan. Yeah, I am Dan Abramson. I'm an engineer also with Salt River Project. My main focus is DER interconnection review. So that's primarily 300 kilowatt systems and above at distribution voltage. My secondary role is focusing on emerging technologies. This is the role that I'll be talking through today. And I'm going to hand it back off to Ryan to kick us off.
All right. So our journey into MESA. So number years ago, maybe 4 or 5 years ago, we started a project to create a microgrid research lab. We were getting some requests from customers interested in microgrids, and we were kind of curious on what that would look like on the distribution system and how it would affect the distribution system. So this all kind of started during the wonderful COVID times, and due to that and all the supply chain stuff, we actually ended up fully commissioning this microgrid late 2024, early 2025. So we've been up and running for just over a year now. Part of that microgrid research lab was we were heavily involved in the MESA technical working group. We had a couple people that were involved there. And so when we built this microgrid lab, we decided to have the microgrid controller follow the MESA standard at the time, MESA application note. So our whole microgrid controller ended up being based off of the January 2019 MESA DER application note. So the whole controller is built fully MESA compliant using all the appropriate addressing, tags, and the available operating modes that MESA outlines. So you can see there in the picture on the slide, the one to the right, there's a little picture of our microgrid. So we have those solar panels and then the cabinets kind of in the substation there in the bottom right of the substation. And then there's a picture of our microgrid controller. So you can see there's a handful of some of the MESA modes that are offered. And our microgrid controller vendor did a great job of implementing all these modes. And this is really our first kind of stepping foot into the whole MESA world, right? So once we got, actually not even once we got the microgrid built, kind of parallel to that, we were working on installing a new ADMS system. And part of that ADMS system included enterprise DERMS. And so what we did was we set up a sandbox version of that ADMS that included the enterprise DERMS. And we use that DERMS and our microgrid lab to communicate using MESA. So the enterprise DERMS system, the control functionalities that are available in there are actually also based off of MESA or 1815.2. And so the implementation between the two made it somewhat easy because we were both speaking the same language, so to speak, right? So over the past year or so, we've been working on that integration and testing and going through some of these MESA modes and looking at use cases and seeing how it affects our distribution system and what can we do with this on our distribution system or for maybe other potential customers and what it might look like as potentially a standard. So I'll go ahead and hand it over to Dan to talk about some of the current stuff we're working on and maybe our future state.
Thank you, Ryan. So today I'll share some projects we're working on that are focusing on future state of the standard SRP and how we're thinking of applying it. So I'll begin with the DER program and how we're using MESA and IEEE 1815.2 to build something scalable. We're currently in a bench study and kind of like a viability phase of the project. It's focused on communicating with and controlling a single Chint 60 kilowatt 480 volt inverter. But the structure is designed to grow. This is the same inverter that Ryan was sharing on the last slide. It's a part of the microgrid lab. So since April of 2025, the Gateway project has focused on evaluating gateway devices for alternative and reliable communication between SRP systems and DERs. The primary objective has been to compare the SEL RTAC and Wago gateway platforms to determine which offers the best long-term viability for SRP. Through programming and testing, we're using the standard as a baseline for how we model the points and modes. Functionally, it's an interpreter between our enterprise systems and the field device. We use DNP3 upstream to speak with the gateway from our DERMS, and then Modbus downstream to the inverter and its registers, because that's the protocol that Chint speaks. MESA gives us a standard data model and control modes for DERs. That means we won't have to reinvent point maps or mode definitions per vendor, and we can try to align to a common utility grade language. Our goal is full read-write control of the inverter and its operating modes through the gateway, so DERMS can control it like any native resource. The project centers on enabling this read-write communication with the Chint inverter on that microgrid lab. This involves using the gateway as an intermediary that translates DNP3 commands to Modbus points. Development has followed the MESA standard to ensure future interpretability and compliance. Right now, we're working through local testing, which is nearly complete, and we are moving through remote testing now. The near-term goal is end-to-end communication from DERMS to the gateway to the inverter. The next step is to turn this into a repeatable standard. Next slide, please. Thank you. So the second slide here, I'll be covering our plans and possibilities for future state with the standard, with a focus on how we would like to implement it going forward. The long-term win isn't just one working inverter, but it's a repeatable integration pattern other projects could plug into. So one plan and kind of the vision could be to publish something like a standard point sheet aligned to the MESA required points and the core control modes we support. That sheet could become a standard sheet that we require, with a model looking to require DER developers to deliver something like an RTAC or gateway pre-programmed to that point sheet and connected to a site controller. And then upstream, we would speak DNP3 to that device. And then downstream, it would just map to the site's assets, whether it's a chin inverter or a BESS or microgrid or something else. That would help us avoid bespoke mappings. So the code like list on the slide here is just an example of what those map points could look like. Each MESA data item lands at a predefined DNP3 address with a deterministic name and scaling. So same recipe every time is what we're looking for. Future phases of the project have yet to be defined, as we have some additional items to work through before getting to a place like this. We have learned quite a few things along the way. So next I'm going to hand it back to Ryan to cover a few lessons learned, and then I'm going to close with a few thoughts after that.
Yeah, so some of the lessons we learned on this journey, I think one of the earlier presenters kind of mentioned the same aspect. So part of MESA and the defined point list, right, is you don't use sequential set of addresses. There's gaps in those addresses. And when we approached the group that handles our DSCADA for the ADMS and said, hey, these are all the points we need, and they looked at the addresses, I've never seen eyes so wide. They were like, we can't do this. Like, we can't have gaps in our addresses. And so that was a little bit of a hiccup to get over. The initial thought was, well, okay, maybe we'll just put spares in between. That would have been a lot of spares. And so being this was a sandbox environment for our DERMs, where we were using this, it wasn't going to affect production. So we ended up going down the road of, well, let's try it. Let's see what happens, right? So we ended up putting all of our points in at the appropriate addresses and leaving those gaps as they were. And so far, we haven't ran into any issues with that. And it seems to be working well. And then one of the other things, I'll mention, coming from a programming background in SCADA and PLCs and things like that, one of the hurdles to get over, right, was especially when we got this microgrid controller and someone else did all the programming, was you look at the tag list and some of the tag names and you're like, whoa, what are these? Like, they're not exactly intuitive, but once you go and actually read the standard and fully kind of understand the different modes and what they're doing and what they mean, the tags make total sense, right? And so that's just a little hump you have to get over, right? And to actually read the standard and try to understand it and understand the different modes and what everything means. I'll go ahead and give it back to Dan.
Awesome. Yeah, and my next point is kind of just going to lead right off of Ryan. So the next lesson learned is kind of been centered around interpreting and implementing all the modes. I think this can probably be defined as just growing pains with learning the standard. So each mode, like constant power factor, volt barb, for example, has nuance. So interpreting like set point precedents and deadbands and fallback behavior took some time. Those growing pains are, of course, necessary to implement the modes correctly and safely, and we're still kind of working through this now. And then I want to close with just the next lesson learned is focused around the benefits I'm beginning to see in standardization. I think the payoff is pretty big. So a standard pattern improves speed to integrate. It would reduce commissioning risk if we start requiring developers to implement, and it could scale beyond single DERs to microgrids and mixed fleets. So in short, the standard gives us a durable foundation. And that is the end of our presentation. I appreciate everybody's time, and I will hand it back over to Ben.
Sounds good. There were a couple questions. I saw the chat's flying by pretty quick, but there were a couple that seemed to be maybe pointed at you. One of them was from Mark Martinez at PNM and said, how many are active in your service territory of these systems?
So the microgrid lab is a standalone lab we're running. We do have one microgrid at a facility. It was kind of a one-off and a variance. Part of the reason that we created the microgrid lab is to begin to define standards that Salt River Project can publish as we start to receive more microgrid applications. But we don't have any past the lab and the one other one that I mentioned. That was kind of a one-off.
Okay. Awesome. And then one other one I had was, are you the interface on the Chin inverter? Was that the 1547 communication interface, or are you guys using some of their proprietary data mapping over their Modbus interfaces?
We're speaking Modbus to the Chint directly. So the Chint's kind of been our test inverter, right, for the gateway.
Okay.
So we're just pulling in their Modbus maps directly.
Awesome. Well, thanks, guys. I appreciate it.
Thank you.
Yep, thanks.
All right. So to wrap this up is Darcy. So I'll hand it back to you.
Thanks, Ben. Let me just advance. All right, so I just want to touch on testing and certification quickly. MESA is standing up an 1815.2 testing and certification program. We're partnering with UL and the Pacific Northwest National Labs. We'll have phase 1 testing available late and hopefully just a couple months here. Functional testing, which we're calling phase 2 testing, will be late 2026 or maybe early 2027. And just to give you a sense of what phase 1, phase 2 is, phase 1 is just semantics. Is everything named correctly and is everything in the right place? We strongly recommend that you go through that vendors go to the DMP3 users group for DMP3 conformance testing before they do 1815.2. That will make everything go more smoothly. And then the functional testing, if you're working for different functions, are they working as anticipated? Commissioning, that would be site commissioning, that's further down the road. I won't go into that today. It's definitely something where it's still in process. This is a table that gives you a quick hit about who is doing what. Again, the DMP3 users group is working on the conformance testing, and then we have UL and NERDLs and other vendors who would be doing the other testing. I'm going to go a little bit quickly through this. As I mentioned before, we're going to have some specific sessions on testing and certifications down the road. Okay, MESA membership. I want to make a quick pitch to join MESA. You get access to the 1815.2 standard for free. MESA has joint IP with IEEE and the DMP3 users group. And if you're a MESA member, we can give you the standard. You can really help shape the future of this standard. The utilities you just heard from have been long-term MESA supporters, and this work would not exist without them. The utilities have been driving the development of this standard and of the testing and certification program. You're our primary supporters. Vendors do come in and support this effort, but it certainly has been utility driven. You can get more lessons learned. We stand up work groups. We want to stand up an implementation work group. We have an ongoing technical work group. The 1815.2 will likely start another round, the next round of updates late this year, early next year. We're not going to wait multiple years. There's much more to do in this space. If you like what you hear, you like what this work is doing, please join us. And just a quick hit, it's usually about $5,000 in a membership fee. Many utilities have been very generous and given us technical allocations. Our membership fees do not cover our operating costs. If you don't have membership budgets, but you have an R&D budget, talk to me. Well, we are super flexible, we're small and nimble, and make good use of these funds. Another way to learn more is we have a spring workshop series. We're just putting the final touches. These will be at like 10 or 11 Pacific time on April 7th, 28th, and 19th. If you want to learn more on Ben's poll, just ask for more information and we will get it to you. You can also just email me, darcy@mesastandards.org, or just go to our website and send us a note through there. But this will directly get you to us. So, and one question I did want to answer about the utilities, or I'm sorry, about the vendors and what they think of this. There's two camps of vendors. There's those that have the proprietary systems and they don't like this very much. And they grumble when they do it because it's expensive, because they have to redo a lot of stuff they've already done. However, they only have to redo once, and then they're in conformance with the standard. And then there are vendors who really believe in this because they see how much time and energy they will save by creating a product once and then just keeping it up to date with the standard. So everyone will get there, but the way we get there is by you guys supporting the work and by requiring it in your technical specifications and your RFPs. Back to you, Ben.
Well, thanks everybody. I appreciate everyone being really willing to hop on today and share some of their experiences with the standard. I did note in this chat recently there was some discussion about how to get a copy of it, and both Darcy and Francis had mentioned that as a MESA member, you can get a copy as part of your membership. And then there's also the link to the IEEE standard was also pasted in there as well. So a couple ways to get a